So at least the note there. So group encrypted transport, what does it do? Its main objective is to do what? To encrypt private WAN technologies. Like what? What are the different technologies that you have for private WAN? MPLS VPN, frame relay in the older days, ATM, Q&Q tunneling, VPLS, etc. All private WAN technologies. So what you need to have is, prior to setting up the Get VPN, you need to have end-to-end routing. This type of VPN does not work on the internet, again, because of what? Private networks will not be able to route on the internet. So it's not really meant for the internet. Okay, so with that in mind, take a look at your topology. I would take 2 minutes and draw this out somewhere so you guys have access to it, because I'm going to be referring back to this diagram over and over again. Take a minute and draw this diagram out. This way, whenever I have this diagram in my mind, whenever I refer to it, you would know the diagram. Yeah, that's one way of doing it. Snippet. Done, everybody? I would use snip, the snipping tool. Now, this is the network, and if you take a look at the IP addresses that I've assigned over here, it's a smaller header. It's about 40 bytes, 40 to 50 bytes. So if you take a look at the addresses that you see over here, notice 192.168, 10, 20, 30, 40, 10.1, 10.2, 10.3, even inside, all private addresses. Do you guys see that? So this is not the internet. This is a private WAN. Again, I don't really care what you're going to set up over there, as long as I have reachability. What I've done is basic routing over here. Router 6 is my ISP. Show IP interface brief. I have all these interfaces connecting towards what? 10, 20, 30, 40, 50. Those are the routes or networks around it. And I am running a routing protocol. Generally, this would be, in case of an in case of MPLS, this would be your PEC routing protocol. I'm routing all of them. Not only on router 6 at the ISP level, what I've done is on the other routers, router 1, for example, I have all the EIGRP routes. So end-to-end router reachability is there. So at this point, if I do ping 10.1.1.10.1.2.1, which is router 2 from 10.1.1.1, reachable. So this is your prereq, that you need to have reachability to what? All the networks that you want to encrypt prior to doing any type of VPN. Why would you want to do Get VPN if I have the other type of VPNs? There are certain characteristics of Get VPN that are better suited for a already routed network. What are those characteristics? I will explain them as we go through it. All right, so if you had to do it on a private WAN, this is a more efficient, better way of doing it. And why is it better? I'll explain that. Good so far? You guys understand the topology? You guys understand that I have full reachability? That's a prereq. Now that's in place, how does it work? So what are the advantages of Get VPN over other VPN types on a private WAN? Number one, the routing overhead is eliminated. I'm not running routing to what? Through my VPN. It's already done. It's prerequisite. It has to be outside the VPN, Whereas with DMVPN or GRE IPsec, SVTI, all of them ran routing through what? Through the VPN. So even the routing updates were encrypted. So it's a more efficient way of setting your VPN up where I'm just focusing on my data traffic. So routing overhead is eliminated. It's a prerequisite. It is a prereq. Good. Number 2, Get VPN allows you a centralized configuration model. What do I mean by that? In Get VPN, you have a special type of router that you set up. Any router, but its functionality is different. This specialized centralized router is known as the key server. The job of the key server is to set up the session key for everybody. It's responsible for setting your transform set. So you don't need to go and configure each and every device. You just configure the key server with the transform set for everyone in your network. And number 3, your interesting traffic, ACL. Is all done on the key server. I don't need to configure any of these parameters where? On the actual devices that are doing the encryption. So it's a centralized configuration model where I configure all these parameters. Once I'm set with the parameters, I'm going to push them. Push them to whom? The actual encrypting devices. These devices that are going to do the encryption are called group members. These are the actual edge devices that are going to be doing your encryption. These devices don't need to have a session key. They'll get it from the key server. They don't need to be configured for any of the parameters for that. They don't need to have a transform set. It'll get it from the key server. It doesn't need to have any interesting traffic ACL. It will be defined at the key server. It will be pushed down. Tomorrow, if you want to make any changes to any of those parameters, where do you need to do it at? In a central location. You don't need to go into each and every device and change the transform set. It's going to be done on a centralized location. Everybody okay with that? You understand that? So that's one of the major advantages that Get VPN brings to the table over the other VPNs, that all these configuration parameters need to be done on the key server. Now, the key server that you define is a router. It's not a server. It's a router, a Cisco router, and it cannot be your encrypting device. So your group member, the one that actually encrypts, and the key server have to be 2 separate devices. They cannot be on the same device. So on the site that you have the key server, you would have a key server and as well as a group member, 2 different devices. So for example, if you take a look at my diagram over here, I'm going to make this guy into my key server. Dedicated, you can do other functionalities on it. You just cannot do the group member functionality on it. So maybe it's doing other routing and stuff. I don't care about that, but it cannot do. I'll move this over here. I did a bit. Good enough. All right, this is your key server over here. These are my edge devices on each site. LA, the edge device is what? This guy. This device is known as the group member. I'm assuming that Dallas, San Francisco, and Miami are smaller sites. So because they're smaller sites, they don't have the key servers. Key servers located in the central location. New York, I'm going to do it for redundancy. So this is going to be my redundant key server, but that I'm going to do later on. But right now, I'm just focusing on my group members. Everybody okay with that? So the actual encryption will be done by whom? This device on this interface. All right. But the parameters for the encryption, for example, the key, the transform set, the ACL, all that will be downloaded to whom? To the group members from where? Here. I thought LA can't be a group member. No, the key server cannot be a group member. R7 is a key server. So in LA, I would have a key server and a group member. So R7 could not be a group member, but not LA. I want to be able to encrypt traffic from LA as well. Think about LA being your headquarters site. That's why I have my key server over there. Understood? Not that much, because it's just its only job is on every 1 hour, it will wake up, generate your session key, and push the session key down to whom? The group members, but on an hourly basis. Remember, the lifetime of a key is what? 3,600 seconds. So for an hour, it will not be doing anything. Not 2 hours, 1 hour. It's the IPsec SA. The 2 hours was for your NHRP, what do you call it? The registration. As many as you want. Can you have multiple key servers? Absolutely. Although you might have 2 key servers, the one that is responsible for setting the key up is only one. That's a redundancy part. So later on, once I set one up, I'll show you the first one up. I'll also show you the second key server. That's why I have this. Is a layer 3 switch appropriate as a group member on a central site? Appropriate as a group member on a central site depends on its functionality, its capability. How good is that layer 3 switch in terms of VPN? What are the data sheet specs for that particular one? Absolutely, very good point. Are your config parameters from the key server to group member secured? If you don't secure them, one of the things that the key server is sending down to your group members is your session key. Guess what? If that session key gets compromised, the rest of it is compromised. It's okay, you're doing it in Los Angeles locally, but the same key server is also responsible for sending the session key to whom? These guys. So it has to be secured, right? And what was used to securely exchange the session key before? What phase? ISACamp or phase 1, right? So what do I need to set up between the key server and my group members? So I can secure my session key. Phase 1. Not just the hash, the entire tunnel. Hash does not secure it. Hash just makes sure it's not tampered with, right? The whole tunnel. Key, encryption, and hash. Remember, in IPsec, what do? Key, encryption, and hash to encrypt my session key. I need to do the same thing over here. So I'm going to be running what? Phase 1 between the key server and whom? All the group members. The whole 9 yards. Remember the ISACEM policy for phase 1? Everything needs to be done. Why? Somebody asked me a question earlier on, that's what I'm answering. Is the session key secure? Yes, absolutely, just like you did for normal IPsec. So I would need to have the key server set up a phase 1 with the group members so that it can send down the session key in a secure manner. Good? How are the group members aware? I'll show you that. We'll get to that. That's the config part of it. Between the key server and all group members, you need to have phase 1. What's my objective over here, guys? The end result that I want to get out of this is that whenever the group member over here sends traffic to this group member, or this group member, or this group member, or this group member, all that traffic is encrypted, right? Using IPsec. Give me 1 second, guys. 1 second, huh? No, man. I'm talking. I have a call. Narvik's calling, so I just wanted to. And now he's not answering. I'll call him back later. Sorry about that. So my objective over here is to be able to encrypt from what to what? Any to any. So everybody should be able to encrypt between what? Group member to group member. All right. So what do I need to encrypt from group member to group member? Remember what I told you. If I want to encrypt the data, what do I need to have? A session key, the what do you call it? Encryption and hash. All right, Jeff. So session key, encryption, and hash. Okay. Now, besides that, I also need to tell it what traffic needs to be encrypted. That is the ACL. All that information will be provided by the key server to every group member. Once I have it, I'm going to set up that phase 2 dynamically between what? All the group members. Everything will be encrypted. Understood? But what do I have with the key server? What am I encrypting with the key server over here? Phase 1. So green is phase 1. So I'm only going to have a phase 1 with whom? With the key server. But I'm going to have phase 2 with whom? Between the other group members. So group member to group member, phase 2. key server to group member, because the only thing the key server is doing for me is sending me the key. That is phase one. Everybody okay with that? Seems a lot of there's a lot of complications in it, but once you go through the config, you'll see this is the easiest type of VPN to set up. Among all the VPNs, this would be the easiest to set up once you understand how it's done. So at the end of this session, you will see how easy it is to set it up. You guys good with this? Key server is not involved in phase two at all. It's giving the parameters to every group member so that they can do phase two, but it itself does not do phase two. So whoever asked that question, absolutely. You got your answer? Who was that? Sinat, right? So how do I set it up? I need to set my key server up. Key server is going to be set up with all the parameters that need to be pushed down to what? All the group members. So I need to configure my interesting traffic ACL. I need to configure my transform set over here. I need to do phase one because phase one is the one that I'm going to be pushing my parameters down. You guys remember those parameters? Help me out. In my case, R7 is my key server. This guy over here for right now. You start by doing your normal IPsec. I need to, on the key server, set up the parameters for what? Phase one. These parameters will be used to set up my phase one tunnel with whom? All my group members. Crypto, ISACamp, policy 10, auth, pre-share, hash, let's say MD5, group 2, encryption, triple des. My key. If I want, I can set the key up individually with what? 10.1. And a separate key if I want to for what? The different group members that I have. Or if I want to keep it simple on myself, got it? Phase one done. You guys are okay with these commands? Have you seen them before? Okay. Why am I doing this on the key server? What's the purpose of doing this on the key server? So I can set up a phase one tunnel with all the group members. Why am I setting a phase one with the group members? So I can push the configuration parameters down to them in a secure manner. Got it? Now, normally, that's a good point to note that you brought up. I need to share the session key. That's normal, right? Normally in ISACamp, phase one, what do I share? The session key, right? And I would have my Diffie Hellman over here to share it, right? Or to generate and exchange it. In normal IPsec, I would have my second tunnel and my session key is derived from phase one, but normal parameters, I would set my transform set over here for my encryption and hash, which would be also set up on the other side to match. So where would I normally set up the transform set? Both sides, right? Agreed? Here, what did I tell you? The group members, I'm not going to do any transform set. It's going to be pushed. Pushed from where? from the key server. So I also will define what? Phase 2 over here. And along with the session key, what else am I going to push down over here? Transform set, because the group member also needs to know the transform set to use. In the previous examples that we were doing, we were setting the transform set where? On the individual devices. Here, I'm going to push it down from the key server so that I don't need to configure the transform set on each and every group member. I'm just going to configure it on the key server and push it down. Understood? The next thing that I did in a normal tunnel is to specify my interesting traffic. Normally, it would have been an ACL, right? Where did I configure the ACL? On the individual devices. Here, where am I configuring the ACL? I'm configuring the ACL on the key server and pushing it down as well. So again, the group members, no ACL requirement. So all these parameters will be done where? On the key server. Everybody clear on that? So the phase 1 over here is a little different in the sense of what? Normal phase 1, what do I actually transmit in phase 1? What's the only thing that gets transmitted in phase 1? The session key. In this phase 1, what am I transmitting? The session key, the transform set, and the ACL. Agreed? That's the whole purpose. I want to have centralized configuration, right? So the older protocol, which was ISACAMP, which I'm still using, had a limitation. ISACAMP had a limitation in the sense that it could only exchange what? The session key. So there was no field for what? The transform set and the ACL to be pushed down in that packet. So they had to take ISACAMP and modify it. Modify it so that it could accommodate what? The transform set as well as the ACL. When they did that, they had to come up with the variation of ISACAMP. That protocol is called GDOI, Group Domain of Interpretation, which is a variant of what? ISACAMP. It's basically like ISACAMP with the ability to exchange, besides the session key, also what? The transform set and the ACL. What was the protocol number for ISACAMP? UDP 500? This one, because it's a different protocol now, GDOI, it is based on UDP 848. It is based on ISACAMP, but it is what? A little different, because it also allows you the ability to push down the transform set and the ACL, whereas ISACAMP would only push down the session key, Group Domain of Interpretations or interpretation. Now, again, go over the difference between ISACAMP and GDOI. Both are phase 1. Generally, when ISACAMP was there, what was the information that needed to pass through ISACAMP? What did I send down from the 2 devices that wanted to set the tunnel up in ISACAMP? Only the session key. Understood? Everybody okay with that? Now, I'm not just exchanging the session key because I'm the key server. I need to push down the session key. I need to push down the transform set. I need to push down the ACL. But there was no field for ACL and transform set in the UDP 500 packet. ISACAMP did not have that capability. So they took the ISACAMP packet, modified it a little bit so that you could also accommodate these 2 other things that I need to transmit. What are the 2 other things? The transform set and the ACL. Hence, when they added that to the protocol, they had to change the protocol. And the new resulting protocol, which is based on ISACEMP, is called GDOI, based on UDP 848. So it's essentially ISACEMP with one difference, that it's adding those two fields to it. Good so far? So what does that tell you? That besides doing the phase one parameters, and notice, I'm still doing ISACEMP, although you will see it's not going to be ISACEMP, it's going to be GDOI. The parameters that I'm putting in are the same old parameters that I use for ISACEMP, because it's based on ISACEMP. All the parameters remain the same. It's just what gets transmitted is different. So when I go to put the commands in, they're still ISACEMP commands. Now, what else did I want to be transmitted across? Transform set, right? We can is too light of a word. We will push transform set and ACLs down to the group members. That's the whole purpose of the key server, is to have a centralized model where I configure everything and push it down. I don't configure the transform set and the ACL on the group members. I configure them on the centralized server, which is the key server. Absolutely correct. Yeah, it is part of the IPsec suite. We will push transform set and ACL down to the group members. Absolutely. Using what protocol? GDOI, UDP 848, which is basically a variant, or the next version of what? I wouldn't even say version of it. It's just another flavor of ISACEMP. GDOI, right? All right. So we agree that I need to configure what? The transform set over here, so I can push it down. Crypto IPsec transform dash set pset. Done. And we need the ACL. Now, this is where you need to be creative. This ACL that I'm creating over here on the key server, it will contain all the different flows that have to be encrypted. Like what? This ACL will apply to this group member, this group member, this group member, this one, and this one. It's a common ACL for everyone. So in this ACL, I need to have an entry allowing 10.1.1.0 to be encrypted towards 10.1.2.0, which is from LA to Dallas. But at the same time, it also needs to have an entry for what? 10.1.2.0 coming to 10.1.1.0. Understood? This same ACL will be applied from LA to San Francisco. So I need to have an entry for what? 10.1.1.0 to 10.1.3.0 and vice versa. Understood? Because it's a common ACL that will be pushed down to everyone. So in this ACL, I'm going to have, let's say, 101 permit 10.1.1.0 to 10.1.2.0. And I will also have 10.1 to 10.3. I will have 10.1 to 10.4, 10.1 to 10.5. Not only that, I will also need to have what? Generally, these ACLs would have been on different devices, but now I need to do it on this one. So the return traffic also needs to put the same ACL. I'm just done with R12 the other devices and vice versa. I need to take care of the same thing from what? Dallas to the other sites, San Francisco to the other sites, Miami, as well as New York. Now, this is where if you're getting paid by the hour, you want control over your network, do it like this. Because the only one that will understand this ACL is you. And when you show this ACL to your boss, it'll be, hey, wow, this is a pretty complicated ACL, right? Serious task. I'm glad we have you on our team. Make sure not to put remarks if you want job security. Just kidding, Kenny. All right. Or you can do a summary ACL, which makes it a lot simpler. What do I mean by that? If you take a look at the networks that I have over here, you notice that everything that I have, all the networks that I have, start with 10.1. So I could technically, if I'm in a rush and I want to get out of there, I'm getting paid for the job rather than per hour, I'll just say 10.1.0.0, 00255.255, 10.1.0.0. So if you take a look at this ACL, what is it telling you to do? Anything that starts with 10.1 going to anything that starts with 10.1. So source to destination, that is 10.1 to 10.1, encrypted. It's like a summary ACL that will accomplish the same thing. You get my point, but that's something that you need to make sure your IP address design is properly done so you can accomplish this. Understood? So this ACL will get the job done in my case. But again, if you want job security, do the other one. Understood so far? Number 4. The transform set does not get applied automatically or does not have the ability to be applied to wherever I need to apply it to. So I'll call it inside the IPsec profile so I can apply it later on. So the 4th step over here is something that you also know. Configure an IPsec profile to attach a transform set. This will be used to link the parameters. Now you do a crypto map. That's similar to that. Crypto IPsec profile. Let's just use the same one that we've been using, iprof, and set the transform set to tset. We haven't done it yet. We will do that next. So up until now, any parameter that you don't know what it's doing, I haven't linked them up together, but individually you understand each parameter, right? Nothing new over here. Look at it and tell me if you guys are okay with that. All right, now, this is where the difference comes in. Crypto map generally is used when you have actual encryption taking place. What did I tell you about the key server? Is it doing any data encryption? No. So actually, I'm not going to use a crypto map on the key server. Now, the question somebody asked was, where's the GDOI part? Configure the GDOI group to link the above parameters to each other. So now I'm going to make it into GDOI and link all these parameters that will be pushed down to whom? To my group members. Up until now, I was just creating them. Now I need to link it up so I can push it down to my group members. Everybody okay with this? So at this point, there's nothing that tells me that I'm doing what? Get VPN. These are normal parameters. As somebody rightly pointed out, where's the GDOI over here? I don't see it. Now I'm going to do it. Crypto GDOI group. And you define a group name, anything you want. It's a locally significant name. Locally significant name. Call it whatever you want to call it. XYZ. Locally significant. What does matter is a number called the identity number. Identity number is a number that the group member will identify itself as. Hey, listen, I'm a member of group XYZ, group 100 or 111. Please give me my session key, my transform set, and my ACL. So I'm going to configure my group member later on, saying that he's a member of this identity group called, identity number is basically the group ID, 111. He's going to try to register to whom? The key server. He's going to tell him, I'm a member of 111. Please give me my session key, my transform set, and my ACL. Those are the three things that I need as a group member. So over here, I'm identifying that this configuration is for what? Group members that belong to the number 111. That's a group ID. Good so far? Now, here, I am going to specify that I am the key server. How do I say I'm the key server? Server local. What does server local say? I am the key server. Now I'm going to set the parameters up for this identity number 111. If I have to do the same thing on the group member itself, I'm going to define the same thing as crypto GDOI, same command. And over here, purposely, I'm giving a different what? Group name, so that you understand this is locally significant. What does matter? He's going to identify himself with the same what? Identity number 111. And then rather than saying server local on the group member, I'm going to say server address IPv4 and followed by the IP address of my server. So on the client, and I'm going to show you that later on, I'm going to specify the server address as 17.7, which is the IP address of the key server. Understood? But right now I'm on the key server. So what do I need to specify? I am the key server. And how do I say that? Server local. Absolutely, you can have different group members having different parameters. Maybe the sales department wants to have different set of parameters. Marketing wants to have a different set of parameters. So when the group member logs in, he will get different what? Parameters for the different groups. Clear so far, guys? Everybody okay with this? Once I say server local, now I need to define these parameters. The way I do it, security association for IPsec, sequence number 5, N20, it's a number, put a number, it doesn't matter, like crypto map 10, same way. It puts you into a subconfig mode. Here you're going to say that to this particular group member, that's a member of 111, give him the profile called iProf. And the ACL is going to be 101. The session key is automatically generated because it's understood, it's implicit that the whole purpose over here is to generate the session key. The session key will be generated. The profile, that's a transform set, is going to be T set, which is these two parameters over here. And the ACL is going to be 101. Good. Now the group member, the key server over here can have multiple IPs on that, maybe a loopback, maybe an interface. What you do need to specify over here, which is important, is my local address. When people point to me, what address do they use? Take a look at this and tell me what address should I use for the key server? What is the IP address of the key server? 17.7, yeah. That's what I used. As long as you use 17 is good enough because you don't know what the address is. In my case, it's 17.7. You can check that over here. This guy over here. All right. So my address, this is my local address is 17.7. That's it. I'm done with my config on the key server. Again, let me recap. Phase 1, why is this required? This is required so I can set up phase 1 with whom? With all the group members. Why do I need to set up phase 1 with all the group members? To exchange the session key, the transform set, and ACL in a secure manner. So if that's the case, I need to define my transform set, my ACL, I define that. I cannot apply the transform set directly, so I need to call it inside the profile. The profile will be called inside my GDOI parameters. All group members must have IP reachability to the key server. Remember what my prerequisite was. Not just to the key server, full reachability. Generally, it's recommended that you use a loopback if you have redundancy. In my case, it doesn't make sense. Why? Because I only have one interface. So if I had a loopback, it really doesn't matter. I could put the loopback, but if it's a single interface, it doesn't matter. Got that, Kenny? But you could do the loopback. What is the server local command? Server local is the one that specifies that I am the key server. Remember, I showed you on the group member, I'll point to a server, whereas over here, I am the key server. That's how I define that I am the key server, by using this server local command. So now once I say I'm the key server, then I define all the parameters that need to be pushed. Yeah, but over here, it doesn't matter, Bill. The reason is, if this interface goes down, it doesn't matter if the loopback's up or not, because I've lost reachability. You get my point, Bill? But you're right. In general, if I had like a redundant path, then because a thing that I would recommend you have for your key server, then point it to the loopback. But this is your local address. This address over here is your local address on where? On the key server. So everyone will point to what? The key server address as 192.168.17.7. Good? Done? Let's paste this to your key server. Copy. Let's go to 7. Everybody good with this? So now all my parameters are done where? On the key server. What do I need to do on the group member? I do need to do phase 1. Why do I need to do phase 1? To get the session key, the transform set, and the ACL. Normally, it is just the session key. But with Get VPN, it's the session key, the transform set, and the ACL. And who do I do phase 1 with? Do I do the phase 1 with the other guys or just with the key server? My phase 1 is only with my key server. All right, so technically I could do what? And be okay with that. Because everybody's going to point towards the key server. They're not going to point phase one towards each other. But so far, guys, everybody okay with this? Now, normally I would have my step 2 as my transform set. Do I need a transform set over here? No, because I just configured that on the key server. He's going to download that. Don't need it. What was the third step? Do you guys remember in your LAN to LAN IPsec? What was the third step? ACL. Do I need the ACL over here? No, I don't need to configure the ACL. So no transform set needs to be configured. No ACL needs to be configured. My third step was a crypto map. But before I do the crypto map over here, I need to define the key server location, or I should say the GDOI parameters. What GDOI parameters? I'm not the server, I'm the client. So I'll say crypto GDOI, same command. I'm going to say clients, just a name. Okay. In here, I'm going to specify my identity number so that I can identify myself to the key server. And I need to point to the key server. So what do I specify over here? Server, not local, address IPv4. So you guys see the difference over here? On the key server, I said server local because I'm the key server and I define my transform set and my ACL. On the client, the group member, I identify myself as a member of 111, and this is my server address. So I don't say server local, I say server address is 192.168.17.7. So it's now going to establish what? Phase one. What protocol am I going to use for phase one? Is it going to be 500 or is it going to be 848? It's going to be 848 because I'm going to apply this GDOI over there. How? That's the next step. So once this is defined on the client, I'm going to define or create a crypto map to be applied to the data interface, wherever the data is exiting. So I'll say crypto map, CRYPTO map, CMAP 10. Normally, what do I say over here? Right? But what did I tell you? I'm not using IPsec ISACAMP. What am I using instead? I'm using a variant of ISACAMP called GDOI. So in your crypto map, rather than saying IPsec ISACAMP, you're going to say, I'm using GDOI. So it knows that it needs to go to the server. Which server? Set group clients. What does clients have over here? Clients is pointing to server 192.168.17.7 with an identity number of 111. Everybody okay with this? Last but not the least, apply the crypto map to the outgoing interface. And I'm done. That's what I need to do on the client. Phase one, set the group parameters, call the group inside your crypto map, apply the crypto map to your interface. Good? Ready to do it? Now, somebody asked me earlier on, how does the group member know where the key server is? Do you see that now? Copy it. Who's my group member? R1 is my group member. My outgoing interface is E00 towards where the data is going. So on R1, let's start with R1. I want to do it in a phased setup. On R1, I'm going to press enter. Right now it's at crypto map. As soon as I apply the crypto map, which has your GDOI on it, it knows it needs to go to where? 17.7 to register. How does it know that? You take a look at it. It says crypto map 10 GDOI, set group clients. Clients specifies what? The server address is 192.168.17.7. It will initiate a connection to download what now from there? What will it download as soon as I do that? The session key, ACL, what else? A transform set. 3 parameters will be downloaded. Yeah? Ready? Enter. As soon as I enter, what happens? It did something and says starts the registration to 17.7. SA TEC was updated. TEC stands for traffic encryption key. Traffic encryption key is another word for your session key. Registration to 17.17 is complete. Install the policy successfully. Let's check now. First thing I want you to see, show crypto, ISACamp SA. Did I do ISACamp or did I do GDOI? You can do the debug for the crypto ISACamp SA over here and it will show you the same thing. I did GDOI, right? Take a look. When I do crypto ISACamp SA, it doesn't say quick mode idle, it says what? GDOI idle. GDOI idle basically means I'm going Get VPN. Now, do you remember I have that transform set, the ACL, show crypto, IPsec SA. Normal IPsec commands. What do you guys see over here? You recognize this ACL? Recognize this transform set. Not only that, it'll tell you that the setup was done based on what? Port 848, which is GDOI. Good. Now, I'm going to rely on my routing to specify where my phase 2 will be done. If I sit on router 1 and I say ping 10.1.2.1, source 10.1.1, is that interesting traffic? Yes, it is. It doesn't care where it's sending the packet to. It'll take that packet, and as I said, it basically will copy the inner header to the outer header. It'll be the same. And use the routing to forward it, but this will be encrypted. It doesn't even know who the peer is. I don't care who the peer is. My key server has told me I need to encrypt this traffic. Using what key? It's my session key. Now, would the other one have a key for this? Did I do this on router 2 right now? No. So will this ping succeed? On router 1, as soon as I implement these policies, I'm bound by these policies to encrypt the traffic. So when I send this ping, it is going to automatically encrypt that traffic and send it across. Forget about there's no adjacency set up. It just basically says my key service told me to encrypt the traffic. I'm going to encrypt it and send it based on my normal routing. All right. So if you take a look at your parameters over here, you will notice that it did encrypt it and send it. So the other side is not doing it because he has not right now done what? Downloaded the session key. It'll be the same session key for everyone or the entire group. It's a common session key. So if I go to router 2, See, it saw a packet saying, hey, I got a packet from that was destined for 10.121 based on protocol 50. I don't have it. I don't know what they're talking about. Yeah, I guess. Now, if I ping 10.131 over here from R2, will this work? Router 3 doesn't have any encryption set yet right now. R2 doesn't. This works fine. How about 4? Works fine. How about 5? Works fine. No problem between what? 2, 3, 4, and 5 right now, right? If I try to do 1, it's going to go, but it won't come back. When it comes back, it'll be what? An encrypted traffic. So not successful. What do I need to do on R2 to set this properly? Do I need to change anything over here? Copy paste it because everything is pointing towards the key server, nothing towards the other client. Maybe in your environment, this might not be an E0 interface, it might be a different interface. Other than that, everything else is okay, it's the same. Copy it. Go to router 2 and paste it. And as soon as I press enter, it's going to go to the key server, download the key. The common key for the entire group. Show crypto, ISACAMP SA, show crypto, IPsec SA. See, the key is set up. That's the same key for encryption and decryption. This is common key. Absolutely. Based on what? That's the whole purpose of setting up what? You look at this parameter, what did I do before I did the download? I set up a secure tunnel based on these parameters over here. Using the pre-shared key, encryption and hash in what? In the policy. Between the key server and the group member. Then, normally with ISACAMP, it would have just sent the session key. That's why I'm using what over here? So because of GDOI, beside the session key, what else is transmitted? That's the whole purpose over here, to secure it. Got it again? So 2 is done. Let's take a look at 2. I have it. Now will this work? That's with any IPsec node. All the IPsecs that I've done so far have the same thing, phase 1, right? No different over here. The session key is done at one time, upfront, on the key server. Once it's done, it's the same session key that is pushed down to everyone. So the first one that initiates the session is where the session key gets generated. And then the same session key is pushed down to everyone. Absolutely, you can replace your auth pre-share with PKI if you're interested in that. But can only be decrypted if configured. Absolutely, and the reason it's good, Kenny, is because it's very efficient now. My whole focus is just on what? Encryption. So if I'm just focusing, if my routing is in place, which is the case in MPLS VPNs, this is the most efficient way of doing it. Because I don't need to worry about the routing and the inside header being different than the outside header, private, public. If my routing is in place, let me go ahead and do this. This is the fastest way of doing it. You get my point? But it's only available, it can only be done on a private WAN, because on the internet, if you have a private network on the inside, it won't route on the internet. That's why my initial statements when I started the lecture were what? That this is good for what? Private WANs. It's not meant for the internet. But it's great for the private WAN. It's a shame that not a lot of people know about it, but if they did, it would be great. So now my packets are getting encrypted between what? 1 and 2, because both of them have it. How about the other sites? Now that you guys get the gist of it, what do I need to do on the other sites? Just copy paste it and I'm ready. That's what I said. It's very easy to do now. Once you do one, the rest of them are basically the same. You can check them on your key server over here. Show crypto, GDOI, members, key server members. This is the best way, Kenny, for that. Absolutely true. And a lot of people, you'll be surprised. I do a lot of high-level consultations for different companies. You'll be surprised at how many IT people still think MPLS VPN is encrypted. Why do I need to encrypt MPLS VPN? It's a VPN. It's encrypted already. And they're not aware that it's not. Yeah, it works with IPsec as well. There you go. Or somebody get somebody at the service provider to sniff data for the competitor. Over here, it tells me yeah, very true. See over here, my group members are 10.1, 20.2, 30.3, 40.4, should be 50.5 as well. There you go. All the group members are registered. So now any data to any data is encrypted. Let's try one over here. Ping 10.1.1.1, source loopback 0, 2, 3, and 4. So I've sent 4 pings. So if I do a show crypto IPsec SA, I should have 20 hits, because every ping is 5 packets. Now, the good thing about this is tomorrow, let's say my company decides to change my, what do you call it? My transform set. I don't want to use MD5, I want to use SHA. Where do I need to change this? Only on the key server. If I want to add some new networks that need to be encrypted, only on the key server, because those parameters are now centrally configured. So that's what I meant over here earlier on when I said that Get VPN allows you to have a centralized configuration model. Does this command make sense now? Or this statement, does it make sense? We'll do that as well. Can you tell the key server to send an update? By default, the key server does what is known as a rekey. You need to set that up. I'll show you how to do rekeying next. By default, again, the rekeying is every 60 minutes, 3600 seconds. You can change it. So every 30 seconds, it's going to regenerate the session key and push it down. If you don't do a rekey, then it needs to have somebody reset the group member. So generally, what you do is you set your key server with what? A rekey parameter or a rekey set of parameters. I'll show you what they are after the break. If a group member brings up another new interface, no, you need to apply the group member, the crypto map on that other interface as well. Any outgoing interface requires a crypto map. All you got to do is take the same crypto map and put it under the other interface. If a new site comes up, you just bring it up. It's going to use the existing session key. You mean a new change in the, what do you call it? In the addressing? If you had the summary ACL, I would have taken care of, but what Kenny is trying to say is there's a change. For whatever reason, you made a change, and I don't want to wait for 45 seconds to do it. All you got to do is go to the group member, what do you call it? Clear Crypto GDOI. They'll have to be pre-registered, so you need to do this. That would force it. Any additional interface, what do you call it? Any additional interface would need to be put with a crypto map again, because the crypto map on the interface is the one that tells it to encrypt. So if you have a new interface on an existing group member, you still need to apply the crypto map, the same crypto map to the other interface. No, you would not be able to use this as a backup of the internet, because if you're going through the internet, then you would need to do something like DMVPN. This is specifically for what? This is specific. Again, you guys are missing the point. What is this meant for? This is meant for a private WAN only. Don't look at it to make it work on the internet. So for those, you have the other technologies like the DMVPN, your IPsec LAN to LAN, all those other technologies. So if you want to do private WAN through here, do the Get VPN over here, and do DMVPN on your internet. What is the command to see the registered group members? On the key server itself, show crypto GDOI KS key server members. Right now, none, because I need to reset them. Flex is internet based, yeah. This is the only one that's private WAN based, which is not a good, it's not a bad thing. You need to just understand horses for courses. This is meant for a certain thing. Use it for that. Don't try to use it for something it's not. Unfortunately, it's not as common. And personally, I think it's the reason for that is lack of knowledge rather than anything else. It's just like the same thing with the SVTI. A lot of people are not even aware of SVTI, the tunnel-based IPsec. They're still doing GRE IPsec. It depends on how you're doing it. See, let's say your key server was set up already as 10.1 to 10.1. It's already there. Your ACL is already there. Now you bring up another loop back over here. 10.1.101. Will this be encrypted? Yeah, it's already part of the ACL, so it's no problems. But if you bring in something like 10.2 over here, then you need to update your ACL to accommodate that. Is it just for Cisco? It is just for Cisco. Well, it depends, Jeff, if you want to encrypt within your enterprise or not. if you do want to do the encryption of your MPLS network within your local enterprise network, yes, absolutely good to do. So if you're doing it with the intent, you're doing MPLS for segregation, but you also want to have the encryption over there, the best encryption for that type of setup, Jeff, would be Get VPN. Cool? No, don't do 0000, because then what happens is you will have issues when this guy wants to go over here for your routing update. Normal routing update, that would also get encrypted. Take a look at the data sheet. They don't have a choice. They generally use something like DMVPN or just normal IPsec site to sites. With routers, Cisco has done a fantastic job in terms of VPNs. No other vendor has the flexibility or flavors of VPNs that Cisco has. Good. Time for a break. When we come back, I'll show you the Rekey portion. How do you set up Rekey? And I'll show you how to set up your redundancy. We'll do that right after the break. All right, Marcin? Coffee time, man. I need to refuel. It is roughly, sure, I'll put it back up. Which part? The key server or the key server or your what do you call it? Man, coffee. Tea is, yeah, it's good, but for teaching and stuff, you need coffee, especially if it's 11:30, 11:15 at night. Is this good? Who wanted to see? Sam. Okay, 11:15 right now, roughly. 11:30, we'll come back and take a look at the other stuff. Let me call my friend up here. No, Mo, I'm in Delhi this week. You guys back? All right, good. So the first thing that I want to show you guys is what do you need to do to set up what is known as rekeying. So this is the initial part, the basic Get VPN configuration. Everybody okay with it? The main thing that people need to understand is what it's meant for and use it properly. If you understand what it's meant for, the rest becomes easier. That's where the confusion a lot of times comes in. You try to use it for something it's not meant for. It's not meant for the internet. Having said that, just to make sure you understand that, can I work with this on the internet? Can I run Get VPN on the internet? The answer is yes. But the requirement for that is that your internal networks that you have over here, these networks that you have over here are public networks. So let's say this is 150.1.1.0. So I'm not using private networks over here, I'm using public. Absolutely. So as long as your internal networks are what? Public, you have enough of an IP address space for doing that, you should have the ability to run Get VPN over the internet, but that doesn't happen very often. You understand why that needs to be there? Because of the inside header and the outside headers, right? So if the inner header over here is private, is public on the inside, I can easily copy it onto the outside and still be routable, right? So if that's the case, it's going to be okay. You good so far? So now the other thing that I want to talk about is the rekeying. What does rekeying mean? The key server has generated a key based on what? This guy registering, this guy registering, this guy registering, this one, and that one. But the key will stay up for how long? 3,600 seconds by default, right? So what happens after 3,600 seconds? By default, it'll just bring it down until another group member comes in, some traffic comes in, it will reinitiate. Rather than doing that, you want to keep the key alive or rekey on a regular basis. Every 1 hour, you want to rekey it so that the new key will be pushed down. For doing the rekey push down, number one, you need to generate a public-private key. On the key server only. You only need it on the key server. Once you generate that, number two, you need to reconfigure your GDOI, your key server, to set up your rekeying by sending a rekey unicasted. Unicasting basically means send it to every one of those group members using the authentication key as the public-private key that you created over here. Use this over here. So a couple of commands over here to set up your rekey, and that way every 1 hour it will send the key back down to the group members. You guys ready to do it? So if I want to do rekeying on the key server, the first thing that I will do, what does rekeying do? The key server will generate and push a new key as soon as the old key expires. All right, two-step procedure. Number one, generate a RSA public/private key pair. Now, one thing that you need to know is I'm going to use the same key pair later on for my redundancy. So if I want to do it as a redundant thing, if you are planning redundancy with the key server, make this public, make this RSA key exportable, so you can export it to the other key server, because they need to share the same key. So normally the way you would have created the key would have been crypto, CRYPQ, key generate RSA, specify the size. Let's create this key as 1024, give it a name, which is called a label. Let's call it Get VPN, just a name. Enter. This would have been good enough. But if you are planning on doing what? Redundancy, I want to use this key on the other key server as well. So make it exportable so you can export it. Understood? I'll show you what the exportable does later on, but at that point, I would need to regenerate the key as exportable. So I'm doing it now because I'm planning on doing redundancy on the network. Everybody okay with that? So now I have this key that is generated. This is a way of validating that the, I hate this. If I go over here, crypto key generate RSA, it generates it and makes it what? Exportable, which will be handy when I'm doing redundancy. Good so far? Now, why do I need this public-private key? Because this is a way of making sure for the group members that they're getting the key from the same key server. So it's a way of validating your key server. So now over here, I'm done with that. Let me check my GDOI name. I don't remember what I called it. I called it XYZ. So I'll go into XYZ, same GDOI group, server local. Under server local, I'm going to set my Rekey transport to be unicast. The default is multicast, but in order to do multicast, I would need to have IPPIM or some version of multicast routing enabled. I don't have that, so I'm going to turn it into Rekeying based on unicast. Not only that, I also need to specify my authentication. My public key is based on RSA and it's called Get VPN. Remember, that's what I called it over here. It's the label. Okay. So now I'm doing what? Rekeying based on unicast. And this is my authentication key. So let me write this down for you guys. Configure rekeying for your GDOI group. Crypto GDOI group XYZ in my case, under server local, Rekey transport unicast, Rekey authentication, my pub key, RSA, and the name. That would make sure or ensure that every time the key expires, a new key is generated and exchanged with whom? The group members. Good, everybody? Show crypto, GDOI, KS, and you can have the Rekey parameters set up over here. I've set it to this. I have not done any rekeying yet, so eventually it will take place because I still have what? This amount of time left. They give you a grace period about 30 minutes left, but it gives you a grace period of a minute before it rekeys. So it actually does it prior to the expiration. All right, clear so far? Crypto, GDOI, KS members, all the members are there. Any questions so far? You guys okay with this reking? It's really small in terms of what you need to do, but I want you guys to understand that. It also has me set up what? My exportable PKI. Good so far, guys? ISACamp is, because ISACamp is between two devices, it's not for a group of devices. When any interesting traffic comes in, it will automatically generate the session key. So in itself, it does not have a rekey concept. It's not like somebody else is creating the key and pushing it down to you. It's between two entities. So in that case, the rekeying will be done at the time that data comes in. With this, because I'm not in the data path, I will push down the rekey over here. That's why they put the rekey over here. It's not there in the normal IP set. Now, what's the last thing that we need to do over here? If you guys remember from our outline, we're done with this now. Get VPN with redundancy. The rekeying is only for the traffic, absolutely. That's why I need to push it down to whom? To my clients. No, the RSA is just for the pre-share key. For the session key, it's always going to be Diffie-Hellman. RSA is only for the first tunnel, not for the second tunnel. The session key is always Diffie-Hellman. Now, get VPN with redundancy. Now, coming back over here, if this server goes down, after 60 minutes, I would not have a new key, I would have an issue. So for that purpose, I can set this guy up as a redundant key server. Okay? Keep one thing in mind. When I set up a redundant key server, they need to be identified as the same. So remember that RSA key that I created for a rekey? I need to take the same key that I had over here and export that same key to whom? To this guy. So they both will have the same RSA key. Good. What that allows them to do is whoever the primary key server is, he's the one that's responsible for generating the key. Let's say this is my primary key server. This is my secondary key server. What that basically means is this guy is responsible for doing what? Generating session key. Once it generates a session key, he will push the session key down to him as well. So he is also aware of the same session key. It is generated by the primary, sent to the secondary. He also sends it to whom? All the group members. Good so far? Now, let's say a new group member comes up or an existing group member comes up. The group members can go to either this guy or this guy to get the key. It doesn't have to go to the primary to get the key. Although the primary is the one that's responsible for generating the key, he will send the key to whom? To the secondary server. The secondary server gets it. He will keep the session key. These guys, it's entirely up to you. Who do you want as the primary server? So for example, this is my primary, this is my secondary server, right? What does that mean? This being the primary, this being the secondary. The key generation, he's the one that's responsible for generating the key. He will send it to him. So now both of them have the same session key. On this guy, I can say my key server is R7 as my primary or preferred one, R8 is my secondary one. On this guy, I can say R8 is my preferred one, R7 is the secondary one. So this guy will actually go and get the session key from here. This guy will go and get the session key from here, but it's the same session key. You get my point? So it's not necessarily I'm the primary, everybody needs to come to me. When I'm the primary, that means I'm going to be the one that is going to be generating the session key for the entire group, TCL and transform set, all that, yeah. But then I'll send it up to the other one. For that to happen, I need to have the same, what? Link speed over here, Bill, doesn't matter because this is very small data. It's maybe in bytes. Your actual data transmission will be a lot more, so it really doesn't matter that much. Not in today's day and age. So he will generate the session key and send it down over here. What is required to be done for that? The key that you generated over here needs to be exported to whom? To this guy. I need to import it over here. So if I want redundancy, what's my first step that needs to be done? Step 1, export the RSA key on the existing what? Key server. Okay, crypto key export RSA. There's a whole big command. I'll just go through it and copy paste it over here. Number 2, import the RSA key on the new key server, the one that I'm going to make into the key server. Okay, how do I do it? For that to be done, yes, you guys remember what I told you? I generated this key called Get VPN and made it what? Exportable. The reason for that is I was planning on doing what? Redundancy. Okay, so let me go ahead and do that on R7. Crypto key export RSA, the name Get VPN, the format is PEM. The key, the format of the key. Terminal means I'm going to put the key on the screen over here rather than putting it into a file. I want to encrypt it using triple des, and the password to encrypt it is Cisco123. So what this does is this is a command that will show you what your public and private key look like. Good. And I'll just copy this for the heck of it so that you guys can see it in your notes as well. Good. So this is your public key. This is your private key. This command will display that public private key where? On the screen of the existing key server. This is the command that will display that for you. Once it's displayed, what do I need to do? I need to go to the other device, which is 8, and import it. How do I import it? Crypto key import RSA Get VPN. The name of the key needs to match. I'm going to do it through the terminal, meaning copy paste it, and the password Cisco123. All right, let me put the command in. So once I do that, take a look what happens. It says, enter the PEM formatted public general key or certificate, which is right over here. Remember, see over here, it says beginning of the public key and then end of public key. Highlight it. Okay. Go to the new device, paste it. When it says end key, press enter. On a blank line, it says now enter what? A private key. Go back over here. Beginning of the private key to the end of the private key. Copy it. Paste it. Enter on an end blank line and type in quit. keep pair imported succeed. Keep pair import succeeded. So let me put this in for you guys over here as well. I'll just copy it exactly the way it is. So if you're trying to do it, you can do it exactly the way I have done it over here. So when you put this command in, this is what shows up. You need to copy paste this over here. And then do the same thing over here. Once this is done, press enter, blank line, quit. And it should give you a message saying what? More secure way of generate a file, you would take that file and email it to your peer on the other side. You have to manually do it on your key server. Whether you export it onto your screen or into a file, it has to be done manually. Because they need to be sharing the same key. It's not creating two keys that you can go to a CA server and they authenticate it. It has to be the same key on both sides. So you export and you import. Good so far? Now, I need to have the same configuration that I have where? So this was step 2, now step 3. No, it's not the session key. It's between the key servers so that the two key servers appear as the same to the other devices. Now, number 3, configure the new server exactly like the old server. Only change the, what do you call it? I would only change the address parameter. Let me explain that. What I'll do over here is I will go to R7, show run, section crypto, copy this, put it in Notepad. I need this transform set exactly the same way. iProf, tset, all this is there. I need the ACL though. Let me get the ACL as well. So step 1, this is step 2. Step 3 is the ACL, step 4, step 5. This is what I meant that you need to change over here. What is my address? I'm doing this on this guy, 58.8. You're complicating stuff that does not need to be complicated more. Got it? You guys are okay with this? So what did I change over here? In the older one, my address was 17.7. Now my address is 58.8. Done? So this is not any different than what I had configured on what? On the other guy, right? Everybody okay with this? The only thing that I changed is my address is 58.8. It's not 17.7. Everybody good with this? So let's copy this onto 8. Done. Now I'm going to set up the redundancy. Configure redundancy on the 2 key servers. How do I do it? First thing, crypto ISACamp, keep alive. Put a number, like it's in seconds. How often do I send an ISACamp keep alive to make sure the other guy is still active? Periodic. So every 10 seconds, I'm going to send a hello packet to the other guy to make sure my device is still up and running. Okay, enable that because this is the way it's like your hello packet that you're enabling between the 2 key servers. Done. Crypto ISACamp, not ISACamp, sorry, GDOI group, what did I call it? XYZ, server local. Under server local, you type in redundancy. Peer address, IPv4 192.168.58.8. I'm on R7. And what would I do on R8? Understood, guys? Now, which one becomes a primary one? That is done by using a number known as a priority number. Higher the better. The number is between 0 through 255. There's no preemption. So if there is a particular one that is the primary one, it will remain as the primary one. Okay? But if there's an election that takes place, higher the better. How do I set the priority? I'll set this one. I want this one to have a higher priority. I say local priority, let's say 150. And this guy, I'm going to set the local priority as, let's say 200. I want R8 to be the primary key server. Understood? Now, what is the role of the primary key server? The person that is responsible for generating the session key and sending it to the peer. Good. So let's do this on 7 first. I don't remember off the top of my head, to be honest with you, Sam. I think it's 100. I think it is 100. Let's do this. I'm not going to set this one over here. It should come up with the default. So copy it. Go to 7. And copy this. Go to 8. Add it. Give it some time for it to do the election. Show crypto. So now it's entering the election mode. This guy should also come into election mode. There you go. Now on 7. No, this is still on the same one. Yeah, it'll come into the election mode soon. Show crypto, GDOI, KS. It's called a cooperative key server. So over here, we're going through. Local priority is 1. Sorry, not 100. It's 1. Show crypto, GDOI, KS. Co-op is cooperative key server. That's what the COOP means. Crypto, GDOI, KS. Co-op. Still going through the setup. Let me just make sure. Shouldn't have gone to primary. Maybe the other one was not up at the time that I brought this one up. This is good. Show crypto, GDOI, KS co-op. Something was amiss. Looks good. Maybe I didn't press enter before. What did I miss over here? This is good. Looks good. Okay, it's there now. It took a bit to come in. Local server role is secondary. Peer session, peer role is primary. So who's the primary right now? This guy. So if I go over here and check, show crypto, GDOI, KS co-op, local role is primary, and the peer role is secondary. The peer is alive. Peer is alive. So now my cooperative key server, the redundant key server, is up and running. Good. Maybe I didn't have the press enter on, I hadn't pressed enter over there. That's why it was giving that error, but now it's up and running. So both of them are what? The key servers now. It's good. Higher, the better. The default was 1. Good, everybody? Now, the last thing that I need to do, configure multiple AS addresses on the group members. What were the group members configured at earlier on? You guys remember this? Right? So I'm going to change it now. Now, this is what I want you guys to see over here. I have 3 group members, or do I have 3? Yeah. I have 5 group members. I have R1. What I'm going to do on R1 is I'm going to say server, and I'm going to put 17.7 first and 58.8 next. Okay, and in here, I'm going to do a no. I can just do a clear crypto GDOI. You see what I'm doing on R1? I'm having it go register to what? 17.7. But 17.7, if you look at it, is not the local server is what? Role is secondary. But doesn't matter, I have a key from it. So he can register to me. So R1, because 17.7 is at the top, it's going to try to go to 17.7 first. If it does not get a response from 17.7, then it goes to 58.8. So let's go to router 1. I'll put the do over here, otherwise it won't clear. Oh, one more thing, guys. Sorry. Do you remember this? On the group member, I only have a key for what? One of them? I need to add it for both. I need to set the key for 58.8 as well. Something's wrong, or is it already registered? There you go. Yeah, 17.7 seems to be down. That's why it registered to 58.8. Big topic. That's not just for this. This is for everything. There's a whole bunch of topic for FVRF and IVR. For right now, don't worry about it. Generally, you're not going to have that. Generally, you don't need to worry about it. Just want to reset this guy over here. Clear crypto GDOI. And I will do the same thing over here because for some reason they've gotten out of sync when I did the redundancy. Now we can do this. I'll go through the election process and get my GDOI up and running first. Let both of them come up and then we'll do it. Okay, good. There you go. Now it's everything's fine. It's registering to what? K17.7. We'll do the same thing over here. But again, what do I need to do over here on R2? Now on R2, I'm going to do it a little different. On R2, I'm going to make this guy above the other one. So who should it go to register? 58.8, 17.7 in case 58.8 is not there. The reason I want to do that, I want you guys to understand that although I have a primary and secondary, they can go to either one and get registered. Yeah, still had 17.7. So crypto GDOI group clients, no 17. Take a look. Now 58 is at the top. So now I can clear it. Clear crypto GDOI. It should go to 58. So if you look at one is going to what? 17. 2 is going to 58. That is correct. Absolutely correct. See, the thing is, there's no load balancing per se, because unless you have a load balancer in the middle where you use a VIP, a virtual IP, and you set the virtual IP as the one that it goes to, otherwise you would need to define what your primary one is on each device. It's not load balancing. I would say it's called load sharing, where both the devices are sharing the load now. Okay, so it doesn't have to go to the primary. So while the session key TSET and ACL is sent over by KS, it is a GM's job to generate phase 2 that info, or no, that's the rekeying. Remember, the rekeying is happening every 3,600 seconds. So it's going to push down the key automatically after 3,600 seconds. Let's finish the other ones off. So what I'll do is I'll do the odd ones to 17, and I'll do the even ones to 58. So now I need to go to 17 for this one. So I'll copy this config. This one should be okay because on our 317 is already there. So I'm just adding 58 as a second one. So this guy, when I clear it, should go to 17, which is fine for the even one. Because there's a pre-config, I need to do a no first. Because there's already a 17 over here. So I'll do a no over here, put this in, and put it back in as, so the order becomes 58 first and then 17. Otherwise, that's what was happening on R2. It was still going to 17. Now I can clear it on R4. This should be 58. All right. And the last one should be the odd one, which is fine. I don't need to do the flipping. But this is how you get the load sharing part done. R5. This one should go to 17. Now, if I go to 7, show crypto GDOI KS members 3, 4, and whatever. So it tells you who they're registered to. Are the members that would have registered to 58.8. And that information is propagated between the two key servers. Clear? So that's your redundancy part. Let me save this file. Oh, I have saved it, or no? Thought I had saved it. Save as. Oh, this is day 4. Good thing I didn't overwrite it. Perfect. So this has my redundancy working as well. So the only other thing that I need to do is put this as my key server as well. Everybody good? So now you have Get VPN up and running as well with redundancy. It is something that I would highly recommend using in a private WAN. Extremely scalable on a private WAN, very simple to set up. It gives you the ability to centrally control a lot of the stuff. Unless you have Juniper. Then you're in the wrong class, right? Now, the configuration replication is not there, so you need to do that manually. The config replication between the key servers, you need to do it manually. So whatever you do on one side, you would need to do it on the other manually. Anytime you have a private WAN, so if your network is running, this is, let's say, an MPLS cloud. So this is your service provider. These are the different sites that are connecting to your service provider using MPLS. MPLS traffic is clear text. So if somebody's running over here, he can run a sniffer and read your data at the service provider. Your objective is to encrypt the traffic going between your different sites. Any type of private WAN, this would be feasible for that. 2 to 3 sites, yeah, you can do that rather than doing, you have an eye on redundant in scalability. If you just have 2, 3 sites, I would still do it. 2 sites, I would not. At least 3 to 4 sites, I would. 2 sites, you can do a point-to-point. All right, over here, I did it for 5 sites, which is not that big of a setup, but it's still useful. Good. Now, the next thing is yep. True, I agree with that, but the only thing is with 2 sites, you would have to dedicate an extra router just as a key server. That's the only thing in terms of the investment that you would need to make for an extra additional router is the only thing that would keep me away from it. With 3 sites, I can at least justify it. All right, ready for VRF send. So that took care of this one as well. So we've done this part so far. Now the next thing is VRFs. What's the objective of a VRF? let's take a look. I'm going to shut these routers off. I don't need this type of topology anymore. Okay, I have a topology for that. You check. Still stopping those routers. This is a different one. I don't need this one. I'll create a new topology real quick that I want to show you guys. Or actually, let me just do it in this thing. It's easier to create a topology over here. This is a GNS, the old GNS. Now the commands over here will be the old commands. So just bear with me. I'll create a new topology in this guy. VRF light. One colon 0/0 goes to 200. 101 goes to 201. 300. 103 goes to 500. 202. 400. 203 goes to 600. All right, so my topology is over here. I'm gonna go over here. Fire them up. This is the diagram that I'm going to be working off of. Save as VRF light and VRF aware VPNs. So let's go over here and save this and open this guy over here. My objective Think about this being a building where you're basically the provider of the services between two different companies. Here I have two companies. Actually, let me do an inner line. This is company A. Okay. And I also have another company, company B. This is router 5 and router 6 belong to the green company. Router 3 and 4 belong to the red company. Okay. In the middle, the two routers, router 1 and router 2, are the routers that you own. My objective on the middle routers over here is to have all the routes that come in from where? From this guy, to be isolated completely from what? The routes that come in from this guy. Why? This is in the same building. Yeah, it might be a service provider. It might be just a like a multi-tenant type environment where I'm the building owner and I'm providing IT services to the tenants. Or it might be a data center that is co-located and some of the routers are owned by you. Okay, why do I want to do that? I want to connect R3, which is the upper network, to its own site. These two belong to the same company. So I want to connect them up over here like this. But the problem is I might have the same networks because these are private networks. I might have 10.1.1.0 over here and 10.2.2.0 over here. Whereas the other company, because this is a private network, can also have 10.1.1.0 and 10.2.2.0. So when the routes come into the routing table, I want the routes to be segregated from each other. All right. So what I want to do on router 1 is I want to create what are known as virtual routers or virtual routing tables. The virtual routing tables that I'm going to create basically break down this router into a virtual logical router, which will have two interfaces. In my case, this is E01 and E02. So I'm going to create one virtual router that will be made up of these two interfaces. I'll create a separate virtual router, which will be made up of E00 and E03. So E00 and E03 over here will make up another router. Any routes that are learned from these two interfaces will be kept in a different routing table, and each routing table will be given a name. So let's call this the green routing table, and we'll call this the red routing table. All right. The routing table that is there by default, the one that you have, is called the global routing table. The normal one, when you do show IP route on a router, what you don't realize is you're looking at the routing table, which is the default routing table called the global routing table. By default, all the interfaces belong to the global routing table. And that's what you're used to by default. What I'm going to do over here is I'm going to break this router down where I'm going to put two interfaces in the red and two on the green virtual routing table. All right. It's not a layer 3 VLAN. It's a separate routing table. I wouldn't even call it a VLAN. It's a routing table. Call it what it is. Good so far, guys? Everybody okay with that? Why do I want to do it? I want to set these two companies, the red company and the green company, to be able to communicate to each other without interfering with each other. So over here, my networks, let's call this network 10.10.10.10 or 0, and call this network 10.20.20.0. The common network between them, 10.12. And ironically, from our perspective, the above networks are the same. So I have two identical customers using the same addresses, but I want to segregate them. My objective is just to segregate them. Okay, and even on their own networks, let's say they have a 10.1.1.0 and they have a 10.3.3.0. This guy over here has 10.2.2.0 and it has 10.4.4.0. These are the networks behind R3 and R4. Here, I have 10.1.1.0 and 10.5.5.0. Some common, some unique. But the whole thing that I want to make over here is acquisition would be a problem. I would need to migrate some networks because they're overlapping. These are two different customers, basically, two different companies. But my middle routers, I want to share the middle routers between the two companies. And that's where the VRF comes in. Understood? From the perspective of 3, 4, or 5, and 6, they have no idea that there's a VRF going on what? R1 and R2. They just have connected to their service provider or their building manager, and they have promised them their routes will be going to their own routes. Clear so far? Let's set these devices up. Let's go to 1, 2. That's the whole objective, to keep them separate. My whole objective is to keep them separate. These are two different customers using the same infrastructure. The reason is when you create a VRF, I could have done it based on sub interfaces, but here I want to keep it simple. So to be able to segregate them, every VRF would have its own interfaces. If I put the same interface in two different VRFs, it would not take. So because I want to maintain that reachability between R1 and R2, I kept two different interfaces between R1 and R2. I could have accomplished the same thing with one physical cable, but then would have to split that into sub interfaces. Does that make sense? At layer 3, they need to be separate. All right, let's start with these routers over here, router 3 and router 4. Okay. Over here, yeah, you're right. So what do I need to do? This should be then 2020, right? So let's do this router first, okay? How do I set up router 3? Router 3 is a simple router. It has nothing special going on over here. It has E0/0, which is 10.10.10. Let's say 3. It has a loopback, 10.1.1.1, and I have a loopback 10.3.3.3. Good. So far, so good. I'm not running routing right now, just to get the routes up and running. On 4, if you take a look at 4 over here, what do I have on 4? E0/0, which is 10.20.20.4, let's say. My loopback 10.2 and loopback 10.4. Good. Let's do 5 and 6 over here, so that I get the routers that don't have anything special out of the way. This is 10, 10, 10, 5. Create a loopback, 10.1.1.1, 10, 5, 5, 5. 10, 10, 10, 5, 10, 1, 1, 10, 6. Let's go to router 6. Good so far, guys. Everybody okay with this? I've not done anything special for the segregation. So how do I do the segregation over here? Let's go to router 1. When I do show IP route, it doesn't show me anything, but by default, all these interfaces that I have, how many interfaces do I have? I have 4 interfaces. What routing table do they belong to by default? The default routing table, which is known as the global routing table. But what I want to do is I want to create 2 virtual routing tables, and I'm running it for IPv4. So the way I do that, let's do it in Notepad. Number 1, create the VRF and enable it for IPv4. So if it's IPv4 or IPv6, you need to specify that. So I'll say VRF definition. Let's call it, the top one was red, address family, IPv4. That's how you create a VRF. Once you create it, step 2, assign the interfaces to the VRF. This is for what? Red. What interfaces belong to red? Let me write it down for you guys because it's not clearly visible. And this is E02. This guy over here at the bottom is E00, and this is E03. Same thing over here, guys. Okay. So when I go to create the red VRF, I need to assign these interfaces to the VRF and assign them the IP addresses. That's my next objective over here. And assign IP addresses to them. So in case of red, what interfaces do I have? E01, which is 10.12.12.1, E02, which is 10.10.10. So interface E01, VRF forwarding, red. So it's no longer in global now, it's in the VRF called red. IP address 10.12.12.1. Interface E0/2. If I'm doing just pure VRF, I don't need the RD. RD is required when I'm running MPBGP. That's why it's called VRF Lite. This is green. Oh no, it's still red. Sorry. And the other interface, IP address 10.10.10.1. Got it? Let me just copy paste it. That gets me my red VRF done. I missed definition. Let's try it again. Looks better. Now, show IP interface brief. I have 10, 10, 10, 12 assigned. If I do show IP route, notice there's no interfaces that show up over here. Why not? When I do show IP route, I'm looking at the global routing table. Okay? What do I need to look at? VRF. So I'll say show IP route, VRF red. Shows me that I have two interfaces over here, E02, which is 10, 10, 10, 1, and E01, which is 10, 12, 12, 1. So at this point, I've configured this interface towards what? R3. And E01 towards R2. R2 is not configured, so I won't be able to do any testing. But let's say I want to ping 10, 10, 10, 3, which is already configured. If I type in ping 10.10.10.3, when I do the normal ping, it looks in the global routing table. So when it tries to look for 10, 10, 10, 3, it's not going to work. Why? The global routing table is blank. So if I want to do a command, if I want to do anything with the VRF, I need to point to it. I say ping VRF red, go check in the VRF called, the routing table called red, and try to ping 10, 10, 10, 3. Now it's going to successfully work because I'm pointing to the right routing table. So this is my routing table for red. So I've completely isolated. It's not in your global routing table. So I have essentially a new router. This new router that I have has two interfaces in it, E01 and E02. Understood, everybody? Similarly, I'm going to create another virtual router on R1, which is going to consist of E00 and E03 towards the other company, which is green. How do I do that? I'll just copy paste it and make some changes. For green, our definition is green. Assign the interfaces E00, which is 10, 10, 10, 1, and E03, which is the IP address is the same. When I had, let's say I had sub interfaces, wouldn't the routes come into the same routing table? Forget that. Would I be able to do this? Let me just show you. Let's do this. And I want you to tell me if this is even possible normally. I'll go to router 1. I'm still on router 1. And I'll paste the green config with the interfaces. Can you assign two interfaces the same IP on the same router? Sinat? Take a look. I can over here because they're now in completely different virtual routers. So the now router 1 is broken down into 3 routers. Completely different routing tables. Mike, you're right, but the problem over here would be later on when I do my routing and I learn 10.1 over here, if it was the same routing table and I learned 10.1 over here, it would be an issue. I need to segregate them. You get my point? Now I have this as one router and this as another router. Where's the third one? The third one right now I don't have any interfaces in. That's a global routing table. Because I only have 4 interfaces, I split it up. 2 for red, 2 for green. Like context on your firewalls, ASAs. So it's virtual routers versus virtual firewalls. Clear? So I should be able to ping 10, 10, 10, 5 now if I use green. Let's verify that. Ping VRF green 10, 10, 10, 5, which is the IP address of router 5. Good? You guys okay with this? Now let's finish it off on R2. Red on, this is R1's config. I want to do the same type of thing on R2. Copy it. That's why I like Notepad. So for red, over there, again, I need to enable it. The interfaces is just, this guy will be 10, 12, 12, 2, and this is, I believe, 10, 20. I'll verify that. E02 over here is 10, 20, 20.2. So this looks good. For red, green again. This is the interface towards R1. My IP is 12.12.2. And this one is, I believe, again, 20.20.2. Same addresses, but on different sides. So R2. Let's make sure this is okay. It's just for green that I got an error. That's fine. Try P interface brief. Do ping VRF red. I should be able to ping 10.20.20.4, I believe. Router 4 on the top. Ping 10.VRF green. 10.20.20.6 on the bottom. And I should be able to ping 10, 12, 12, 1, which is the router on the other side. Same thing for green. That's VRF light, guys. Almost. I want to do one more thing over here. And that one last thing is your routing. You understand this so far? What have I done? I've broken down this router into 2 sub routers. Cool. I'll be communicating over here with the red and over here with the green. So all the commands you run on the conventional router can be on a VRF, or as long as you have, not all of them, but a lot of them. Like show IP interface brief, it is show IP interface brief. But telnet, ping, those type of things, show IP route, those will be with the VRF name. Now, let's say I want to run routing. I'm going to do 2 routing protocols over here. I want to run EIGRP between R3 and R4. Basically, the red network over here plans on running EIGRP. Let's say EIGRP 100. How do I run EIGRP 100? Let's do the normal one on R3. Help me out. That's what I'm going to show you. On R3, what interfaces do I have? They're all 10. So I can say router EIGRP 100. No auto network is 10. Clear? Simple enough. And the other router in the red domain is R4. This one also, I believe, has only 10 interfaces, 1020, 10.2, 10.4. It's router EIGRP 100. No auto, network 10. Clear so far? Right? Now, if I go to router 1 and I want to run EIGRP now, where? I want to run this interface in EIGRP. I want to run this interface in EIGRP so I can exchange the routes over here. So I want to run EIGRP here. I want to run EIGRP here, here, and here. It is a way of saying it. Yeah, correct. It's basically a virtual router, whereas VLAN is a virtual switch. You know the word VLAN, what does it stand for? Virtual LAN, right? Virtual LAN, which is your switch or your layer 2 network. This is virtual routing and forwarding, basically a virtual router. Now let's go to R1 and take a look at it towards R3. If I go on to router 1 and I say router EIGRP 100, and after that I go ahead and put my commands in. Let me just do it over here. So now running this guy is done. Running EIGRP as the routing protocol. R3 and R4. It was basically the same config, wasn't it? Good. Now on R1, if I do router EIGRP 100, no auto dash summary and network 10, which includes 10, 10, 10, and 10, 12, 12, 12. The problem with this is pointing to your global routing table. This is pointing to your global routing table. So what I need to do is I want to run it. I need to enable EIGRP, but underneath the VRF. How do I run it within the VRF? This number is insignificant. I can keep it as 100. I can keep it as 1. Doesn't matter. I'll purposely change it so you guys understand that. This number is not significant to me. What does matter, where I'm going to run EIGRP, is under the address family IPv4 for VRF red with an autonomous system of, this is where the autonomous system comes in. This is the one that needs to match my peer. All right, address family for IPv4, I want to do it for this VRF called red. Address family allows me the ability to run different address families like IPv4 or IPv6 on the same router, but not globally. I want to do it for the VRF called red with an autonomous system of 100. Now all those commands make sense. Now these commands now are going under what? The VRF red. This number is insignificant. What matters is this number over here. Understood? So now if I do this, I've established a routing neighbor relationship between R1 and R3 over here on the VRF. Take a look. Go to router 1 and paste that config. As soon as I say this, I should have a neighbor relationship pop in with 10, 10, 10, 3. Now, if I want to check my routing table, nothing in there. But if I check my red routing table, I would see that I have 2 routes learned. And if you want to be more specific, EIGRP, I've learned 10.1 and 10.3. Similarly, on R2, to complete the EIGRP, I'm running EIGRP now between R3 and R1. I'm running on R4. Let's do it on 2. 2 is very similar over here. This one, again, it really doesn't matter. What matters? This AS number. Good? Clear? I'm going to do this on R2. So now I have a neighbor with router 1 on one side and 4 on the other side. Take a look at this topology and make sure you understand. Now I have a full EIGRP neighbor relationship from R3 to R1, 1 to 2, 2 to 4. So now I should have reachability between what? 10.1.2 and 10.1.1 and 10.2.2.2. Take a look. Let's go to 3. and check my, over here, there's no segregation. It's just a single router. So all my routes are in my global routing table. Just do EIGRP 10.2, 10.4 from the other side. So if I do a trace to 10.4.4.4, source of 10.1.1.1, I'm going to 1 to 12, 2 to 4. So I'm going through over here. Everybody okay with that? But now if I learn the same routes from R5 from green, guess what? They will not be in my red routing table. They will be in my green routing table. I'm going to run, just for the heck of it, I want to run OSPF over here so I can show you OSPF. Everybody okay with this part over here? Can we enable for routing on the global level? What do you mean? Normal router would be router global is global. Didn't get your point though. What you have been doing is normal. Duplicate addresses, absolutely. It's a different routing table. So now I have 3 routing tables. What are my 3 routing tables? On the same router. Actually, let me put the router in black. I have one routing table, which is over here, which has one interface here, which is E02 and E01. Then I have another routing table over here. One here, E00 and E03. Technically, let's say I had another 2 interfaces. Let's say I had E10 and E11. I can keep them in the global. So this would be my 3rd routing table, which is the default one, which is global. Correct. Basically, you have 3 virtual routers now. And these routes can be the same, identical routes if you want. Duplicate address is absolutely okay, because now I have 3 separate routing tables. The config, don't look at the config. Config is all in the global. It's when you look at the config, it's not inside a virtual router. The config part, it's the same common config. It's just the routing portion of it, it's going to be in separate ones. So if I go over here, no, not too much for this one. The main reason for doing VRF is so that I could show you VPN aware VRFs. You cannot reuse the interfaces. An interface can only belong to one VRF or global. So you cannot share it. Would you need to physically cable the VRFs together to route between them? Means over here to here? No, that's route leaking. That's what somebody was asking me earlier on, whether I'm going to cover it or not. If I want to go like this, right? Is that what you're saying? It is possible to do that. That is called route leaking. Don't do it for routes that are overlapping, but if there's any unique routes, you can do that. You do that a lot on the MPLS VPN type of setup. Beyond the scope over here, because that will take you on a tangent. My main objective of the VRF is to have you for you guys to have a basic understanding of what VRF is so that we can run VPNs on it. Clear? All right. How do I run EIGRP as, OSPF as a protocol over here? So on R5 and R6, that you can do. That you can do. When you do a sub interface, that can be put into different VRFs. Yeah, you can, but I want to keep it simple over here so I can copy paste it. OSPF 1, this is normal, right? This is a normal router. So over here, I'll say 10.0.255.255.255 area 0, and I can copy this and paste it to R5 and R6. So R5 and R6, I've enabled what? OSPF on. Now over here for OSPF, it's a little different. OSPF is different anyways. In OSPF, what you do is you don't need an address family. What you have the ability to do when you do router OSPF, whatever process ID you want to pick. One, I generally keep one away because one generally is run with your global routing table. So I start with 2, VRF green. You don't have a concept of address family over here. So you're basically associating the process with green. You could do that anyways. That has nothing to do with the VRF though. That's a normal OSPF configuration, but has nothing to do with the VRF. Yeah, not progress, but process IDs. I get your point. So on R1, OSPF 2 green and run it what on the VRF green. So the process ID is the one that makes it into, that process ID is now linked to green. Similarly, over here, I'll do the same thing. Oops. Do the process IDs need to match? Not necessarily. They could be different. It doesn't matter as long as the process ID in OSPF is unique, locally unique or locally significant. So R1. As soon as I do that, it should establish a neighbor relationship towards R5. Take a look. Give it some time. It is OSPF, so it's a little slow. I'm getting those routes. Okay. Similarly, I'll do the same thing on R2. For green, show IP route, VRF, green. And I can do it specifically for OSPF. 10.2 and 10.6 are there. Give it some time. OSPF is a little slow for it to converge. I'm still in two-way with R1. The two processes on what? On the two different routers? Yeah, the process ID, the router IDs need to be unique. Just like normal OSPF. So it's no different than normal OSPF. Just because you're running it in the VRF does not make it any different. So now if I do green, you will notice that I have all the OSPF routes. All right. So if I look at router 6, I have 10.1. Do a trace to 10.1 from 10.2 or 10.5. Not 10.5, I have 10.6. I'm going to 2 to 1 to 5. How do I know to go there? Because of my segregation over here. Show IP route, VRF green, which is different than show IP route, VRF red. So whatever route enters, or packet enters the router through an interface that's part of a VRF, it'll be using the appropriate VRF. Make sense? You guys are okay? You understand what I'm trying to do over here? My main objective over here was to do what? Segregate. This is one, and this was the other network. I am the provider. Provider doesn't necessarily mean be a service provider. It is a provider, maybe a colo manager, maybe a building manager providing IT services. All right. And my objective was to allow red to connect to red, green to green, but I didn't want to dedicate a router for red and a router for green. I used the same router, accommodated both the networks and keeping them segregated. I'm going to stop over here. We'll do the VPN part tomorrow. But before we do that, I just want you guys to understand what that would bring into the picture. VRF is still just segregation. Let's say this was a cloud network over here. Can somebody sniff this data? Yes, it's still clear text. So if I want to implement IPsec in conjunction with the VRF, how do I do it? How do I make my IPsec configured with VRF in the network, which is called VRF aware VPN? So the main objective over here for me to go over the VRF is for the people that have never seen a VRF before, to at least have a concept of a VRF, basic concept of a VRF. But my main objective was not the VRF. It was just to get the network up and running. My main objective is to show you what? How is a VPN run on top of a VRF? That's the main objective. And that's what I'm going to show you tomorrow. Don't miss tomorrow. We have a lot of good stuff still coming up. So we are over here now. I've shown you VRF Lite so far. So this part is done. These are the things that are left for tomorrow. VRF aware IPsec VPN. Then we do IKV2 and then Flex. I'm going to share everything with Katie. She'll make it available for you guys. But give her, I think this week she's off or she's busy, so probably next week. No problems at all. Thank you guys. I want you guys to go ahead and now implement Get VPN out there. That would be awesome. I know, man. I know that. It is rocket science until you see it. It is really simple. You need to do it a couple of times. It makes it a lot simpler. Will 3850 switches work? You need to take a look at the data sheet. I'm not sure though. Can VPN be done on your switches? Yes, you can, but you need to take a look at the data sheet. Which VPN, which switches support what VPNs? The switch will tell you that. Absolutely, Bill. That's the way to do it. And the right iOS, yes, Alan. Very important. Anybody looking for a, thank you. Anybody looking for a CCIE security? I have a boot camp coming up in LA, on the 9th of July. Yeah, I'll do that as well. I'll give you the information about not route switch security to Micronics. Tomorrow I'll give you that information about the annual package as well as the bootcamp coming up. There's a special pricing that Micron is running on it. I'm teaching that class, so if you're interested, I'll let you know about that. No, I'm doing it online, but I'm doing that. Yeah, I'm running SP as well. If there's enough people, I'll come. I've lived in LA for about 17, 18 years, so that's home. You guys from LA, most of you guys, or no? All around? Oh, all over the place. Come home. I feel home. Arcadia, my God. My first job was in Pasadena. So I used to live in Diamond Bar, and Arcadia was always on the way, 210. Wow, this is pretty diverse. Different time zones, huh? Yeah, that's what I was there about, I think 4 or 5 months ago in December. I traveled between India, Dubai, and London. I have 3 sites. So those are the 3 locations that I run. That was there at the time I was there as well. All right, guys, see you tomorrow then. We'll talk about the class of the annual package as well as the boot camp. Take care, guys. Good night.